7-4 is all about division properties of exponents. Now we just learned about what do we do when we're multiplying things with exponents, and now we're going to talk about what do we do when we're dividing things with exponents. Now the very first property is quotient of powers. So when we have two things raised to a power with the same base, okay, same base is important again, and we're dividing them, then we're going to subtract the exponents. So a to the m divided by a to the n would be the same thing as a to the m minus n. Now a little bit of sort of mathematical proof of where we get this property from would be right here. So if I have 3 to the 5th over 3 to the 3rd, hopefully you'll agree with me that 3 to the 5th is the same as 3 times 3 times 3 times 3 times 3. And 3 to the 3rd is the same as 3 times 3 times 3. So if I write it out like this, okay, which you don't have to do, I'm just kind of showing you why this works mathematically. You can see that the 3 of the 3's on top will cancel out with the 3 3's on the bottom. So we'll just be left with 3 times 3 on the top, which is the same as 3 to the 2nd, which is, that's how we get, okay, 3 to the 5th over 3 to the 3rd would be the same as 3 to the 3 to the 5th minus 3, which would be 3 to the 2nd. So this is where we get the property mathematically. So if I was doing a problem, for example, 6 to the 7th over 6 to the 4th, that would be the same as 6 to the 7 minus 4, which would be 6 to the 3rd. So let's do a few of these. Here I got 2 to the 7th over 2 to the 2nd, so that's going to be 2 to the 7 minus 2, which would be 2 to the 5th. Here I have x to the 4th over x to the 3rd, so that would be x to the 4 minus 3, which would be the same as x to the 1st, and we don't have to write the first power, so we can just write x. A little more complicated here. If I have something like this, the first thing I want to do is simplify the bottom using my properties of multiplication that we learned in 7-3. So this is on the bottom, d squared e squared. Now I just want to look at these individually. So let's look at the d's first. So d to the 4th over d to the 2nd is d to the 4 minus 2, right? And then if I look at the e's, that's going to be e to the 3 minus 2. So then we end up with d squared e to the 1st. So d squared e. Do the same thing over here. I just want to look individually at the ones with the same basis. So this is 3 to the 1st. So this would be 3 to the 1 minus 2. Then over here, this is going to be 4 to the 3 minus 4. And then over here, this is going to be 5 to the 5 minus 3. So then, 3 to the 1 minus 2, well that's 3 to the negative 1st. 4 to the 3 minus 4, that's 4 to the negative 1st. And 5 to the 5 minus 3 is 5 to the 2nd. Now since these are both negative exponents, they gotta go to the bottom. So I'm going to end up with 5 squared over 3 to the 1st times 4 to the 1st. Now since these are pretty easy exponents, I could go ahead and multiply that out, so I get 25 over 12. Okay? Now the next thing we need to talk about is how do we divide numbers in scientific notation. Now we talked in 7-3 about how do we multiply them, and dividing them is similar. Okay? So if I have 3 times 10 to the 10th divided by 6 times 10 to the 6th, the first thing I want to do is write it in fraction form. Remember, the fraction bar means division. And then I'm going to do the same thing that I just did. I'm going to group the things that are alike. So 3 over 6 is going to be 0.5. Okay? 3 divided by 6, I should say. And then 10 to the 10th over 10 to the 6th would be 10 to the 10 minus 6, which would be 10 to the 4th. Now it says write my answer in scientific notation. Now notice that this number here, 0.5, is not greater than 1. So I'm going to have to move my decimal one spot to the right. And when I do that, I have to subtract 1 from the exponent on the 10 because I'm going to move it one less spot when I would convert it out. So in scientific notation, this would be 5 times 10 to the 3rd. Okay? So that's how we divide numbers in scientific notation. Now the next property we want to talk about is when we have a quotient raised to a positive power. And this is very similar when we have a product raised to a power. The power essentially kind of distributes itself to each part of your quotient. So if I have a over b to the n, that's going to be the same as a to the n over b to the n. And again, just a little mathematical proof for you that this works. If I have 2/3 to the 3rd, hopefully you would agree with me that that's 2/3 times 2/3 times 2/3, which if I multiply across is 2 times 2 times 2 over 3 times 3 times 3, which is the same as 2 to the 3rd, 3 to the 3rd. So that's where this property comes from. So if we look at a few examples of this property, this would become 4 squared over 7 squared, which would be 16 over 49. A little more complicated one. Now, this 4 has to go to every part of the product and every part of the quotient. So this is 3 to the 4th, d to the 8th, over e to the 4th, f to the 4th. Okay, so it goes to every part there of my product. Now 3 to the 4th is, let's see, 3 times 3 times 3, I believe it's 81. 81 d to the 8th over e to the 4th, f to the 4th. Okay? So it's important there, it's really easy to just write 3d to the 8th on the top here, and ef to the 4th on the bottom. Remember that these are like products. It might help if you put them in their own little parentheses. Okay, so that power goes to all of them because of our power of a product property that we learned in 7.3. Okay, one last one here. So again, I have to remember that this 2 squared and x to the 6th. And then on the bottom here I'd have xy to the 6th. Now I can simplify that further. Well, 2 squared is 4. So I have 4x to the 6th on top. And then I have x to the 6th, y to the 6th on the bottom. Now again, look here. I have division of things with the same base. So x to the 6 minus 6 is x to the 0, which remember is just 1. So this would become 4 over y to the 6th. Now one last property to talk about here is what happens when we have a quotient raised to a negative power. Okay? And we had one of these, I think we came across in 7.1 that we talked about a little bit, but here's the actual rule that we can use. What we're going to do when we have a quotient raised to a negative power, the very first thing we do is we're going to flip the fraction. Okay, see here it went from a over b to b over a. And when I do that, I'm going to change the power to positive. So a over b to the negative n is the same as b over a to the n. And then I use the property that we just learned, that the power goes to each part of my quotient. So these can get kind of fun here as we go along. So this, again, the first thing I'm going to do, I'm going to flip it, and I'm going to raise it to the positive third power. So then that would be 4 to the 3rd over 3 to the 3rd, which 4 to the 3rd we know is 64, and 3 to the 3rd we know is 27, so we could write 64 over 27. Now let's try this one. So again, the first thing I want to do, flip it. And that's going to be raised to the positive second power. So then I have y to the 6th over 2 squared x to the 4th. Remember, it's got to go to each part. So that would be y to the 6th over 4x to the 4th. Okay, one last example here. I got two quotients raised to negative power, so I'm going to flip them both. And then apply the power, so 3 squared over 2 squared times, this is going to be 2 to the 3rd n to the 3rd over 6 to the 3rd m to the 3rd. Okay, so I got some simplifying I can do here. 3 squared is 9, 2 squared is 4, 2 cubed is 8, and 6 to the 3rd is 216. Now, I can do a little bit of cross-reducing here before I go ahead and multiply. This 8 can become a 2, this 4 can become a 1. Now, 216 and 9, I'm pretty sure that 3 goes into both of those. Let's see. 3 is going to go into 216 72 times, I think. Actually, 9 probably goes in there too. 9's going to go in there 24 times. So we could actually make this 9 a 1 and this 216 a 24. Okay, so then I'm going to end up with 2 into the 3rd over 24 m to the 3rd. Now again, I can reduce that even further, okay? And this is one place where mistakes sometimes happen because people forget about this very last part here. So 2 over 24, again, those can be reduced to 1/12, right? So my completely simplified answer here would be n to the 3rd over 12 m to the 3rd. Okay? So we want to make sure that we are also reducing the fractions that we come across here as we go. I think, yeah, those are all our properties of division. So again, let me know if you have any questions tomorrow, and I will see you then.